equation, and that could be a multi-step equation. So a little refresh real quick on solving an equation. You don't have to write this down, I just want you to pay attention. All right, if you were going to solve this equation, can somebody raise their hand and tell me what you would do first, like?
Multiply 2 with 3.
Because that's called what? The parentheses are distributed. So 2 times 3x is 6x. 2 times 5 is 10. After you distribute, what do you always look for? Like terms. And I do have like terms. This 6x and this minus 4x. So 6 minus 4 is 2x plus 10 equals 10. And then it's just a two-step equation. I'll subtract the 10. So 2x equals 0. Divide by 2. And x equals 0. 0 can be an answer. Okay? That's a skill that you're going to have for today. So if you don't remember that skill, that means you're going to have to pay extra attention today. Okay, now, systems of equations. There are 3 ways in this unit that we're going to learn how to solve systems. The first one was to graph them, and I was looking for where they intersected, where they cross, okay? That was the answer to both of those equations. Today, we're going to do something called substitution, where we substitute one equation into the other equation and are able to solve the system for that. And then there's one more way that we'll get to in a couple weeks. Okay, now, think of the word substitute. If I had a substitute teacher in here, where would I be? Not here. I would be removed and somebody would be in my place. Okay, a substitute takes the place of something else. Just like when you're at a restaurant and your food comes with french fries, but you want macaroni. You say, can I substitute macaroni for my french fries? Which means your french fries are no longer on that plate and the macaroni is in its place. That's what you do with substitution. You remove something and you put something in its place. Okay? And with substitution of equations, the goal of that is to get an equation that has the same variable in it. Okay? Because you right now, in math, in algebra 1 and algebra 2, you cannot figure out what an equation equals if it has 2 different variables, unless you know one of them. Okay, so substitution is going to allow us to plug one in so that we only have one variable and we can solve for it. Okay, so solving systems of substitution, so this is just part 1. Number 1 is the part that people have the most trouble with. Okay, one of your equations, one of them, doesn't matter which one, has to be solved for y or x equals. Okay, I don't like how they don't put x equals. But one of your equations, one of them has to either be y equals or x equals. Not both of them, one of them. Sometimes step 1's already done for us. And for the first 2 problems, step 1 is going to be done for us just to get us in the groove. Okay? After one of your equation is y equals or x equals, you're going to take that and you're going to substitute it. So that means you're going to take it and put it into the other spot for y or x in the other equation. I don't like how they use second equation, so we're going to say other equation. After you substitute it in, you're going to then solve that equation just like we did on the other slide. The other slide is what it's going to look like. You're going to have to solve that and get a variable. Like you'll get x equals 0 or x equals 3 or y equals 7, something. And then the last step is going to be to substitute the value that you just got for x or y in either of the original equations to find y or x.
This makes sense.
It'll be okay when you see it. This is completely brand new. You will have never done this before.
Sherman probably has.
Okay. And the last thing that you're going to do is you're going to check your answer. And you're going to check it just like we checked it with graphing. where you plug x and y both in, and they should both make the equation true. Okay. All right, so we're gonna constantly go back to these over and over and over again, okay? So pay attention. If you're tired today, wake yourself up because you're gonna be really lost. Okay, so the problems, the directions, solve each system of equations by substitution. Be sure to show your work. And I'm gonna be clear on something. When we take our test over this unit, there are 3 separate directions on that test. You must solve by graphing. You must solve by substitution. And then the last one will say, you must solve by elimination. So if you do substitution on elimination, it'll be counted wrong. Or if you do elimination on substitution, it'll be counted wrong. You have to follow the steps that it's telling you, okay? All right, now, step 1 says that you must solve one of the equations for y equals or x equals. So when you first get a system, remember system means 1 or 2 or more equations, ask yourself, does one of the equations say x equal or y equal? And you all would say yes, and it says y equals. Does everybody see right here? That this one, step 1 is already done for us because it says y equals. We always want one of the equations to say x equal or y equal for step 1. Okay, and I see that it says y equals. So here's your highlighter. Okay, you're going to highlight what that y equals. So y equals 3x. You're just going to highlight just the 3x part. And you're going to take that 3x and you're going to substitute it into the other equation. So everybody look up here. See how this says y equals? Yeah. That means they're saying you're plugging that in for the y. So this 3x is going to go in the spot for the y because it says y equals. It goes in for the y. If it said x equals, it would go in for the x. Okay, so what I'm going to do now is I'm taking this 3x and I'm putting it in for this y. So that will give me, right here, see how it says x plus, and then in that y spot will now be its substitute. Its substitute is 3x equals negative 32. So I take one equation and I plug it into the other equation because I want to make an equation that has just the same variable in it. So see how this one had a y and an x? This one had a y and an x. Now this one just has x. And I'm able to solve that. I know how to solve something like that. So step 3 says you're going to solve that. So this is like a 1x. So 1x plus 3x is 4x equals negative 32. And then I'll divide by 4 to find what x is. So x equals negative 8. Now that is not the answer. Because the answer, how many variables do you have in these problems? 2. So that means you have to find both of them. You can't just find one of them. You have to find x and y. So step 4 says that you're going to take that negative 8 and you're going to substitute it back into either one of the original equations. It does not matter which one you put it in. So if Karen wants to put it in the first one, but then Samantha wants to put it in the second one, it doesn't matter. It's still going to come out to be the same. Okay? So I'm just going to put it in the first one. So I got x equals negative 8. So where am I going to plug the negative 8 in on this top one? The x, because it's x equals. So I'm going to say y equals 3 times x. Well, we just said x was negative 8. So 3 times negative 8 is negative 24. So my answer is x, comma, y. Which that would be the same answer that you would get if you graphed it. So if you were to graph both of those equations, they would both cross at -8, -24. But back in the day when they were graphing these, solving them by graphing, sometimes they got points that were huge, or sometimes they got points that crossed in a decimal place, and they weren't able to find it just by doing graphing. So they came up with substitution and elimination to be able to find those answers. Okay, we're gonna check them. I'm not gonna force you to check them all, but if you're struggling or you feel like it doesn't look right, you should. Okay, so I'm gonna check it, and remember, to check them, they both have to be true. Okay, so I'm gonna erase this just so we can see it. Okay, so if I check it in the first one, y equals, we said y was -24, so -24 equals 3 times -8. What is 3 times -8? So it works in that one, but it has to make both of them true, not just one of them. So I'm gonna go back and I'm gonna check it in the other one. So x plus y, well, x is -8, plus y is -24 equals -32. What is -8 plus -24? -32. So I know that this is the right answer, 100%. Like I said, we're gonna do a lot of these, so we're gonna get a lot of practice. All right, so number 2, solve by substitution. So I asked myself, do I see at least one of the equations that has an x equal or y equal? Yes, they're actually both y equals, right? Okay, so I'm just gonna go with the top one. So here comes my highlighter. I'm gonna go with the top one, and I'm gonna highlight net 9x minus 2. And I'm going to now, Brody 1, plug that into the other equation. Since the first one says y equals, guess where it's going to go in for? Y, because it's y equals that. So I'm going to put it in for this y right here. So I'm going to take this 9x minus 2, and I'm going to put it in for that y right there. So I'm substituting one equation into the other equation. So now when I go to write that, I'll have 9x minus 2 equals 3x plus 10. So I substitute one equation into the other equation. Yep.
Isn't this just a multi-step equation now?
All right, why don't you all solve that for x real quick? I'll wait. So move all your variables to one side. Move all your x's to one side. So like move the 3x over. Hold your hand up with the answer. Hold your hand up with the answer. Oh, Simpson's got to poop. Yeah.
I have answered.
All right, what's the answer?
X equals 2.
X equals 2. So I'm gonna subtract. Hush. Okay, well we're gonna see. So I'm gonna subtract the 3x. I'm talking. Rude. I'm talking. So 3 minus 3 is gone. 9 minus 3, that's 6x minus 2 equals 10. So I'm gonna add the 2. So 6x equals 12. Divide by 6. And x equals 2. Okay. Now a reminder, these systems have 2 variables, so I have 2 answers. So I'm now going to take that 2 and I'm going to plug it back in to either one of the originals. So if Brody 1 wants to take the 2 and plug it in the first one, you go Brody 1. If Brody 2 wants to plug it in the second one, you go Brody 2. It doesn't matter. Okay? All right, I'm just going to plug it in the first one because I'm a creature of habit and I typically just do the first one. So I'm going to take this 2 and I'm plugging it in for x because it's x equals. So it's going in right here. So y equals 9 times x. So what did we say x was? 2. minus 2.
16.
So that's going to be 18 minus 2, which is 16. So the answer is 2, comma, 16.
He's so upset.
All right. Okay, I want to talk about something real quick. All right, we're just going to check this one out loud. Okay, so we just checked it in this first one because we did 9 times 2 is 18 minus 2 is 16. Check it in this one. What's 3 times 2? 6. What's 6 plus 10? 16, so it is right. It is the right answer.
So we plug the whole thing.
Yeah. So on this number 3, we're going to start it off together and I'm going to let you finish it. Do you see an x equal or a y equal?
Yes.
Yes, the first one. So I'm going to take that first equation, that first one, and that's like a negative 1x, right? It's like a negative 1x. And where am I going to plug that in at? In the y, because it says y equals. So I'm going to put it right here. So I'm going to put it right here. Now, here's something that's going to throw some people off. That's 6. What does 6y actually mean in math?
6
multiplied by y. So when I go to put this in, yes, 6 times the equation. So I'm going to have 5x plus 6. But in for that y is going to be negative 1x, I guess I should say. Negative 1x plus 4. And then that equals 13. So I took it that time and I substituted it in. If there's a number in front of the variable, you also have to include that there. That's 6 times y. So it's 6 times the whole entire negative x plus 4. So I'm going to give you all a minute. I want you to solve that. So that's just like what we went over at the beginning. Distribute first. All right, so let's see what we got here. So I distribute 6 times negative 1x is negative 6x. 6 times 4 is 24. Then I still have that 5x there, equals 13. All right, some like terms, 5x minus 6x is negative 1x plus 24 equals 13. Subtract the 24. So that's negative 1x equals negative 11. Divide by negative 1, and x is positive 11.
How did that negative times
All right, right now I want you to take that 11. I want you to take that 11 and I want you to plug it back in either one of the originals. Take x equal 11 and plug it back in either one of the originals to be able to find your y. Did you already get it?
I just want to know if this right there, the top one would be negative 11?
It would be like, it would be a negative 11, yep. Because it's like a negative 1 times 11. Let's see.
Oh, you're right.
All right, so I'm gonna take x equals 11, and like I said, I'm a creature of habit, so I'm gonna put it in right there. So that's a y equals negative, and then 11 plus 4. So that's y equals negative 7.
I just
All right, let's check it together out loud. So I want everybody to listen. This is good practice for you. So I'm gonna plug 11 in for x. So what's 5 times 11? 55. What's 6 times negative 7? Negative 42. So what's 55 plus negative 42? 13. So I know that this is the right answer. All right, we're going to flip it over. I'm going to let you all do number 4 on your own. Okay? I want you all to be quiet and do it on your own. Flip back over, look at your notes. It is like identical to the last one we just did. It's different numbers. Just like number 3 on the front.
I didn't get it from where you had that.
Sims covered your mouth.
What's 7 from?
Oh, I put it on. You're so funny, Catherine. Nope.
You just called yourself
I know you're not.
What did I do?
You just assault Austin. Look here, I have a boxing. Second or third.
I did that so we can talk about that. We're talking about boxing match on this.
Oh, I did this.
Other than figuring it
All
out.
right, we're gonna go over it. Hush. Stop. Okay, so you will notice up here that I already circled it. You've got to ask yourself, do I see an x equal or a y equal? And the answer is yes. The second one is y equals. So the thing that we've been highlighting, that's what I'm going to highlight right there. That's the y equals, which means it goes into the other equation for y. It's going up. So that means that I have negative 3x plus 4, and then that y is substituting out, and this y is substituting in. So that's 3x minus 5, and then equals 7. So this one was flip-flopped. All the other ones we had y equals on the top. But this one was on the bottom, but it's still the same process. You're still plugging it into the other equation. And a lot of us that were struggling on this, it's because we plugged it back into the same equation. It says that you must plug it into the other one. So since this one's y equals, it goes into the other one. And then I distribute, so that's positive 12x minus 20. Combine like terms, so that's 9x minus 20 equals 7. Add the 20, so 9x equals 27. Divide by 9, and x equals positive 3.
I got that after you fixed it.
I didn't ask who got it. I already looked at who got it. All right, then I'm going to take that 3, and I'm going to sub it back in for either one of these. I said that I'm a creature of habit, so you'll see me typically pick the first one. So this is x equals 3, so I'm going to put it in for x. Now, if you chose another one, you're still going to get the same answer. So I'm doing negative 3 times 3 plus 4y equals 7. So that's negative 9 plus 4y equals 7. I'm going to add my 9. So that's 4y equals 16. Divide by 4, and y is 4. The 16 divided by 4 is 4. My answer is 3, 4.
It's really not that hard.
It's not, it's just a lot. It's a lot. All right, we're going to do the next one together because I want to talk about it. Okay, when we're looking at number 5, do you see either one of those equations say x equal or y equal? No. So now we're getting into some of them that don't have step 1 done for us. So here's your hint. You always want to choose the one that doesn't have a number in front of it. So do you see any of the variables in this problem that do not have a number in front of it, Taryn?
The first one, y.
The first one is with this y. I'm going to solve it for that y because it's the only one that doesn't have a number in front of it. So that makes it a little bit easier. Okay? Brecken? Sit up.
Brecken.
Franklin, you're on my last nerve. I've had enough. So this one, this y right here is the only one that's by itself, so I'm going to solve for it, which means I need to get rid of this negative 2x. How would you get rid of that negative 2x? Add 2x. So I'm going to add 2x to both sides. So that's going to give me y equals, and then I can't put those together because they're not like terms. One has an x and one doesn't. And so I'm just going to rewrite it as y equals mx plus b. So mx would be positive 2x. The b would be negative 3. And now it's just like the other ones. Now here's the thing though, that every year I run into with this, is kids go to plug this in and they plug it in the first one. No, the first one is this one. And step 2 says that you substitute it into the other equation. So this equation is this one. So that means I'm going to have to plug this into that second equation. So it's going to have to go there. You can't plug it back into the same one or you're going to get 0. 0 equals 0. Okay, so I'm taking that first equation that I solved for y, And I'm substituting it into the second equation. So that'll be negative 6x plus 4, but in for that y spot is going to be that second equation, that 2x minus 3. So why don't you all finish that one out? So be finishing it out, solving that, distribute, and then combine your like terms. All right. So 4 times 2x is 8x. 4 times negative 3 is negative 12. Combine my like terms, so negative 6 plus 8, that's 2x minus 12 equals 4. Add the 12, that's 2x equals 16. So x equals 8. All right, so right now, if you didn't already find y, I want you to take that 8 and plug it back into either one of the original problems. You should never plug it back in the y equals 2x minus 3. Because if you made a mistake, you won't be able to catch it. So always plug it back in one of the 2 original that they gave you. All right. So I'm going to take that 8 and I'm going to plug it back in. I'll just do the first one again. So it's 2x and I've got x is 8. So it's 2 times 8 plus y equals negative 3. So that's 16 plus y equals negative 3. So I'll subtract 16 and y equals negative 19. Is that right? Preston, is that what you got?
Yeah, I got
No, I got
13. I'm not the whole problem though.
Well, hold on, let me look.
Minus 3.
Yeah. Oh, Miss Wilson, because you wrote over it, look. That was a negative. Sorry, I didn't realize that was negative because I wrote over it. So I'm going to add 16, which is 13, sorry. But I get to write over it and I can't see it. Alright, 8 on 13.
I'm terrible.
Well, we're going to do some more practice. No. No. All right, so what we're gonna do is we're gonna go to IXL and I'm gonna put it in your Schoology folder so you can find it. I'm only gonna make you do 4. That's it. All right, whoa, hold on. We're talking. Shh. Hush. Okay, so I'm gonna find it on here. I'm gonna put it in the Schoology folder for today. Hold on. Am I gonna make you check them on the test? No.
You should check.
But you should if you have time.
I can barely solve I'm just gonna have to get 4 correct answers.
All right, let me pull up Schoology real quick so I can put it in today's. Okay.
Miss Wilson, when do you wrote out the paper?
Probably.
Is that is the ISL gonna be homework or do we do it now?
Just do it now. All right. So you should be, guys. Whoa, listen. Last time we did this, some of you all made the mistake of not signing in to IXL when you got on there. So make sure you sign in, and then you can click this. It will take you. If you look at this first problem here, see how it already tells you that x equals 6? Oh, I didn't unfreeze it. See how it tells you x equals 6 there? That means that all you have to do is what? Put the 6 in. So I know that this is going to be 6 here, and then I'm going to plug 6 in here. So 6 minus 3y equals 18. I subtract the 6, which is 12, divided by -3, which is -4. I don't want you doing it in your head, though. I want you to do it on paper. Okay? On paper. You can put it at the bottom, the very bottom of this notes paper or something, but I don't want you trying to do them all in your head.